To do today is go back to log equations, some simple log equations, and show you that you can actually solve some of them very easily. You don't have to use the a plus b rule and the a minus b rule all the time, but it is best. So let's take an example. Let's take this example here. Log of x to the base 5 plus log of 5 to the base 5 is equal to 4. So one way to do this is to say 5 times x, log 5x to the base 5 is equal to 4. See, I'm using the log a plus log b law. So according to that law, the bases are the same. I can multiply those two, and then from here what I did is I changed it to index form, and I say, well, 5x is equal to 5 to the 4, and then 5x is equal to 6 to 5, and therefore x is equal to 6 to 5 all over 5. Now this is one way. This is using the law, log of a plus log of b is equal to log ab. But the same example can be done very easily using another method. So the other method will be, you spotted this. You spotted this section here. And you decided to change base here. So what you'll do, you'll say, well, log of x to the base 5 plus, you take this and you put it in the calculator, you see. So before you put it in the calculator, you're going to say log 5 divided by log 5 is equal to 4. So you're changing base there. And you're welcome to do that. Then you'll end up with log of x to the base 5 plus 1 is equal to 4. Then you'll end up with log of x to the base 5 is equal to 4 minus 1. Log of x to the base 5 is equal to 3. And then once again, from here you'll change to index form, and you'll say x is equal to 5 cubed, x is equal to 125. So we're just doing one example to demonstrate to you that, look, an equation could be solved in two different ways. So the choice is yours. In maths, sometimes we depend on a hunch. Hunch means the idea that comes to your mind. If a person read this and log of a plus log of b came to the mind, they'll use method 1. If a person saw this and decided to change base, then they will use what I will call method 2. Well, the choice is yours, and as you read it, you will get some kind of hunch, and you will work with your hunch, or you'll work with the idea and the rules that come into your mind. So that rounds up simple log equations, and that's where we're going to end with log equations. And what we're going to do next now is we're going to do some examples, general examples on logs, either solving equations or just simplifying, etc. So that's what we're going to do next. Alright, sorry, I've got a slight change of program. I'm going to give you 5 more log equations, and you are at liberty to do these 5 equations any way you like. I think the last time I stopped at an exercise, or let me just call this exercise 9. I'll just call it exercise 9, but it starts from number 6. Log 500 minus log 5 is equal to x. Number 7. Log of x to the base 2 plus log of 5 to the base 3 is equal to 4. Sorry, this is base 3. Number 8. Log of x to the base 2 minus log of 2 to the base 2 is equal to 32. Number 9, log of 3 to the base x plus log of 27 to the base x is equal to 2. And finally, number 10, log of 64 to the index x to the base 2 is equal to 40. Alright, so the last one you can just do it correct to one decimal place. Alright, so here are some examples. You can stop the DVD now, try them, and come back to have them marked for you. Other solutions. If you got this, maybe you want to use the log of a minus log of b law, so it will be log of 500 divided by 5 is equal to x. That gives you log of 100 is equal to x, and you'll check log of 100 in the calculator and you get 2 is equal to x. So that's your final answer, x is equal to 2. Right, let's move on to number 7. Number 7, you had log of x to the base 3 plus log of 5 to the base 3 is equal to 4. Well, in this example, you got no choice. You have to apply the log of a plus log of b law. So you're going to say, well, log of a plus log of b tells you that you are allowed to multiply these two numbers. So you'll say log of 5x to the base 3 is equal to 4. And once you've reached this stage, you'll decide to change it to index form. So you'll say, well, 5x is equal to 3 to the 4. 5x is equal to 81. X is equal to 81 divided by 5. And therefore x is equal to 16, 2. Alright, so that was number 6 and number 7. Number 8, we have log of x to the base 2 minus log of 2 to the base 2 is equal to 32. Let's suppose I don't want to use a minus b. I've seen this and I've decided to change base. So I'll say that log of x to the base 2 minus log of 2 all over log of 2 is equal to 32. So log of x to the base 2 minus 1. Log of 2 divided by log of 2 will give you 1. If you don't know that, just put it in your calculator. Log of 2 divided by log of 2, you get 1 is equal to 32. So log of x to the base 2 is equal to 32 plus 1. Log of x to the base 2 is equal to 33. At this stage, I will change it to index form. So this goes there, and x is equal to 2 to the 33, and I can leave it like that in power form. So that was number 8, and the final answer is x is equal to 2 to the 33. Number 9, log of 3 to the base x plus log of 27 to the base x is equal to 2. So here we're going to use the rule log of a plus log of b. That means log of 3 times 27 to the base x is equal to 2. That will give you log of 81 to the base x is equal to 2. At this stage, we'll change to index form. 81 is equal to x squared. 81 is equal to x squared. So I could say x squared is equal to 81. So x is equal to the square root of 81. See, x is a base. So the base can't be negative in logs. So I'll only take the positive root. So x is equal to 9. Number 10, log of 64 to the index x to the base 2 is equal to 40. So if you like, you can use the power law and bring the x to the front. So you'll have x log 64 to the base 2 is equal to 40. Now, I can change base here. See, here. To make my life easy, I will change base. So I will say log of 64 divided by log of 2 is equal to 40. X into. Now when you put log 64 divided by log 2 in the calculator, you will get 6. So 6x is equal to 40. Right? Then x is equal to 40 divided by 6. X is equal to, and when you put that into the calculator, you'll get 6, 6 recurring. But you want it correct to one decimal place, so it will be 6, 7. That brings us to the end of equations, simple equations in logs, and we hope you got all right. What we're going to do now is we're going to give you a mixed exercise. We're going to call it exercise 10. It's going to be a mixed exercise, and you may have to do whatever each question requires. So here is question 1. 1. You're required to solve for x. And you are told that log of half plus log of x is equal to 2. In number 2, you are required to simplify. Log of 1,000 minus log 4 minus log 2. Log 25, sorry. Minus log 25. Number 3, again you are required to simplify. Log of 8 to the base 2 plus log of 16 to the base 2 all over. Log of 81 to the base 3 minus log of 8 to the base 2. And finally, number 4, you are required to solve. 10 is equal to 3 to the x. And of course we want your answer correct to one decimal place. Alright, so try these 4 examples and then return to us to mark them for you, so you can stop the DVD and try the examples and return for marking exercise. Okay, welcome back from your little exercise. So we're trying to solve number 1. Log of half plus log of x is equal to 2. Well, we'll use the log a plus b rule, which means I can multiply this 2. Therefore, half times x. Half times x is half x is equal to 2. Now I'm ready to change this to index form. But the base is not written here. Well, the base is understood. The base is not written. It is understood to be 10, so I'm now writing it down. And now I'm going to convert to index form. So half x is equal to 10 squared half x is equal to 100. 10 squared is 100, and therefore x is equal to 100 divided by half. So x is equal to 200. Alright, that was number 1. Number 2 was log of 1,000 minus log 4 minus log 25. Well, if you like, you can just use the a minus b. Well, you could put this in a calculator straight and just get an answer. Or you could do it like this, step by step. Log of 1,000 over 4 minus log of 25. That gives you log of 250 minus log of 25. Right, and that will give you log of 250 over 25, which finally becomes log of 10, which is now, the answer is 1. Alright. At 3.3, log of 8 to the base 2 plus log of 16 to the base 2 all over. In the numerator, you can see clearly the bases are the same. In the denominator, the situation is different. You got log of 81 to the base 3 minus log of 8 to the base 2. So, let's handle the numerator first. So if I do the numerator first, I could say that I'm going to use the log of a plus log of b. So it will be log of 8 times 16 all to the base 2 all over. Now down here, I cannot use the rule a minus b because the bases are different. I cannot use the rule a minus b because the bases are different, so I have to do each one separately. So what I'll do, I'll change base here. I'll make it log 81 over log 3 minus log 8 over log 2. Because if I change the base here and I change the base there, I'll get those answers and I can subtract them. So the numerator becomes log of 6 8 48, 128 to the base 2 all over. Now this, if I put it in the calculator, log of 81 over log of 3, I'll get the answer 4. When I put this part in the calculator, log of 8 divided by log of 2, I will get the answer 3. Now, so the denominator becomes 1. Now let's look at the numerator. In the numerator, I want to change base again and make it log of 128 all over log of 2 all over the denominator, which is 1. Now I put log of 128 over log of 2 into the calculator and I will get the answer 7. When I put that in the calculator, I get 7. So it's 7 over 1, which finally simplifies to 7. So that was 3.3, and that is the final answer, which is 7. Alright, here we have number 4. 10 is equal to 3 to the x. So my only choice is to rewrite this in log form. This is already in index form. That's in index form. So better I write it in log form. So if I write this in log form, I'll end up with log of 10 to the base 3 is equal to x. So that's the first thing I do, convert it to log form. Then I'll change base. I'll say log of 10 divided by log of 3 is equal to x. Then I will take the calculator and I'll punch in there log of 10 divided by log of 3. And the answer that I'll get correct to one decimal place is 2 comma 1. So x is equal to 2 comma 1. Alright, so at this stage you should be taking a small break and then return after a short break, take a walk, have a cup of tea, do some exercise and come back, and then we're going to give you another little exercise. We're going to call it exercise 11, and in that exercise we'll want you to just apply the log laws and expand or rewrite whatever is given to you in another form. So we're going to move on to exercise 11 shortly. Exercise 11, you can expand or rewrite in another form. So number 1, log of x squared y cubed to the base 3. Number 2, log of x over y to the base 3. Number 3, log of m to the base 5 to the index log 100. Number 4, log 100 all cubed. Log 100 all cubed. And number 5, log of 6 to the base 4. So in each example, we want you to either simplify or just expand it or just rewrite it in another form using as much of the log knowledge that you have. Alright, so you can stop the DVD, try the examples and come back for a review. Okay, so you are back. That's good. Now on the board we have number 1 and number 2. So let's see what we do. Well, number 1, we are applying the log law in reverse. Log of a plus log of b is applied in reverse. So if I expand this, it will become log of x squared to the base 3 plus log of y cubed to the base 3. And if I wish to expand this further, then this part will become 2 log x to the base 3 plus 3 log y to the base 3. See, the second part here, I'm now bringing the index to the front in each case. That's what I did there. Right, this is the reverse. Now we're going to apply the reverse of a minus b. So it will become log of x to the base 3 minus. Remember, the top one is written first. The second one is written second. So log of x minus log of y to the base 3. Alright, now let's see if we can fit in number 3 here. No, I like to do number 3 on its own. Okay, we'll move to number 3 now. Of m to the base 5 to the index log of 100. Alright, so when you get a question like this, you don't have to get frightened. That's the index. That's the index. So that will have to come to the front. So if that comes to the front, it will be log of 100. Remember, that moves together. Log of 100 comes to the front, and then I'm left with log of m to the base 5. But now, if you have a good look at this part here, log of 100 simply means it is 2 log m to the base 5. Or this example could have been done differently. You could have changed the question yourself. You were given this question here. You could have changed the question and said, well, it is log of 5 log of m to the base 5. But this log 100, you know it is 2. You can check in your calculator, it is 2. You could have changed the question like that straight away. And then simplified it, and you get 2 log m to the base 5. So there were 2 options to handle number 3. Right, in this question you got log of 100 cubed. So you got to be careful. That 3 is not an index here. Right? It's not here. It's log of 100 all cubed. So you follow the instructions. So what is log of 100? It is 2. So it will be 2 cubed, which is 2 times 2 times 2, which is 8. Or if you wanted, you could have written log of 100 times log of 100 times log of 100, which gave you 2 times 2 times 2, which still gave you 8. Alright? But you have to be very, very clear that the 3 was not an index on the 100. It's the whole thing that is cubed. Right, that was number 4. And finally we'll do number 5 now on the board. Number 5, you had log of 6 to the base 4. Well, what you will do in this case, you'll change the base, log of 6 all over log of 4. Then get the calculator to help you. Log of 6 divided by log of 4 will give you 1,3. Just put this into the calculator. Log of 6 divided by log of 4 and correct 1 decimal place, you will get the answer 1,3. Alright, so that's where we're going to round up with logs. So this will be the end of logs, and we do hope you enjoyed studying logs. And remember, the word log on its own in maths has no meaning. It must be attached to a number, for example 1000, then only it has meaning. Otherwise the word log on its own will mean a piece of wood that you might find on the seashore or somewhere else. So it's adios amigos till we meet again. So that's the end of logs. Hello there, welcome. We're doing a little bit extra now. We're doing log graphs. So what we're going to do is draw a very simple log graph. Let us suppose we are told sketch y is equal to the log of x to the base 2. If we are required to draw this graph, well, we'll first have to find some ordered pairs. See? So there's your x and there's your y, and you'll have to find some ordered pairs. Let's suppose I take quarter, half, 0, 1 and 2. And let's go one more and say 4. So what am I doing? I'm trying to find, so y is equal to, in the first case, y is equal to log of quarter to the base 2. You see, x is quarter. So I'm replacing x by quarter. So y is equal to log of quarter to the base 2, and I can change the base over here. And I will get the answer from the calculator, and it will be minus 2. So that becomes minus 2. In the same way, in the next example, y is equal to the log of half to the base 2. You change the base and you end up with minus 1. Right? In logs, we don't consider 0. We don't consider 0, right? We don't consider 0, so we leave that out. Then you're going to look at y is equal to the log of 1 to the base 2. And if you change the base over here, you get log 1 over log 2. Put that in the calculator and you'll get the answer 0. And similarly for 2 you'll get the answer 1, and for 4 you'll get the answer 2. So you make yourself a table of values like that before you can draw the graph. I'm going to remove this working because I need the space to draw the graph. Okay, so you'll have a system of axes. Here's your 1, 2, 3, 4. 4, 3, 2, 1, 0. Here you have minus 1. Here you have minus 1 going down. And here you have minus 2. And here we have 1. And here you have 2. And that's your y-axis. And that's your x-axis. Of course, you're going to draw this accurately on graph paper. Nevertheless, we can also manage the rough sketch. Right, so now there's 1, so half is here. And quarter is here. So we need to be clear where quarter is and where half is. Now let's plot the point. When it's quarter, you got minus 2. Quarter and minus 2. Don't mind, I'm just going to write these numbers on the other side. So it becomes easier to, I can write the numbers on this side. So for quarter, it is minus 2. Quarter and minus 2. Half and minus 1. Right. When x is 1, y is 0. When x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. See? Right. So you can see that the shape of the graph is like this. Cuts the x-axis there, comes down here, goes down here. Go through there. And that's y is equal to log of x to the base 2. Right. Now an interesting point about this graph is that we can use numbers less than 1. We can use numbers less than 1, but we will never use 0. We will never use 0. That means this graph will keep coming closer and closer to the x-axis. But it will not touch the x-axis. So the y-axis, it will not touch the y-axis. So the y-axis becomes an asymptote because that graph will come very, very close to the y-axis, but it will not touch the y-axis. So that's your log graph, provided your base is a whole number. Alright, so what we're going to do now is we'll give you a little exercise and you will sketch the graph of, so let's put it here. This is an exercise for you. Let's call it exercise 1. Sketch y is equal to log of x to the base 3. Sketch y is equal to log of x to the base 3. Now, you try something, let's see what you do, and then we will help you to do that graph. Stop the DVD and try drawing that graph. Alright, you have to draw the graph of y is equal to log of x to the base 3. So now, for you to draw this graph, you have to choose the powers of 3, you see. Powers of 3 means 3 to the 1 is 3, 3 to the 0 is 1, 3 squared is 9. So you'll use these numbers, 1, 3, 9. So suppose I used 1, 3 and 9 there. Then on this side you will use 1/3, 1 over 3 and 1 over 9. 1 over 9. Right? So if you take the first one, you'll say log of 1/9 to the base 3. Then you will change base, log of 1/9 all over log of 3. Put it in your calculator and you will get minus 2. So similarly you'll get minus 2 here. Next one, log of 1/3 to the base 3 is equal to log 1/3. Be careful how you put this in the calculator. Make sure you put it in a bracket. All over log 3. And you get minus 1. So you get minus 1. And similarly you continue. Log of 1 to the base 3 is equal to 0. Log of 3 to the base 3 is equal to 1. Log of 9 to the base 3 is equal to 2. Keep changing base, putting it in the calculator, and you get the values 0, 1, 2. Right? So once again, here's your, just showing you how we got those figures. And here I'm not showing you the change of base. Either you know it or you can change the base yourself and put it in the calculator and then get those answers. Alright, so we got the ordered pairs now and we can draw the graph. Alright, so once again, I'm going to remove these workings and let's create a system of axes. There we are. And a rough sketch will do here. -1, -2, that's 1, that's 2, and let's say that's -1, that's 1, 2, no. Now what we're going to do, alright, so that's 1, 2, then that will be 3, and then what I'm going to do, I'm not going to draw right through till 9, but let me do this. I can do that and write 9 here. So when I do that, I mean I'm telling you that look, I have left out the other numbers. Right. So let's see. So you got your 2/3, you got your 1/3 over here. Right, that will be 2/3, that will be 1/3. Right. So 1/9 will be somewhere here. So when it's 1/9, it is -2. When it is 1/3, it is -1. When it is 1, it is 0. When it is 3, it is 1. When it's 3, it is 1. When it's 9, it is 2. Once again, you can see the shape from here, up here, cutting the hair. And that is y is equal to log of x to the base 3. So what happens now? This graph will never touch the y-axis. So the y-axis becomes an asymptote. So the y-axis becomes an asymptote. That means that log graph will come nearer and nearer the y-axis, but it will not touch the y-axis, and therefore the y-axis is an asymptote. Alright, now what we're going to do is we're going to draw a graph where the base will be a fraction. Our next graph will be a graph where the base is going to be a fraction. In these two examples, the base was a whole number. Right, we want to sketch y is equal to log of x to the base half. So this time the base is half, and that's your x and that's your y, and I decided to just help you put in those numbers there so that you can draw the graph. Now, in the first case, what will we have? We'll have log of Now x is replaced by quarter, so we'll have log of quarter to the base half, and y is equal to that. Now if I change base of that, it will become log of quarter divided by log of half. Now if you put that in the calculator, log of quarter divided by log of half, you will get 2. So the answer is 2. The next one will be y is equal to log of half to the base half. You change the base here, it will become log of half over log of half, and when you put that into the calculator, you get the answer 1. So you'll get 1, and then you'll get log of 1, y is equal to log of 1 to the base half. Put that in the calculator, after changing base, you'll get 0. So you get 0, then y is equal to log of 2 to the base half, and that will become log of 2 over log of half, and when you put that into the calculator, you will get minus 1 for that, and similarly you will get minus 2 for that. Alright, so if you want, I will just do the last one for you. Y is equal to log of 4 to the base half, which is equal to log of 4 divided by log of half. Put that in the calculator and you will get minus 2, and you get minus 1. Okay, so that's how you build your ordered pairs, and you take those ordered pairs and you plot them and you will get the log graph. So what we're seeing now is we're seeing the ordered pairs for this particular function, and we're going to draw this graph. So draw a system of axes. There we are, and that's y, that's x, and that's 1, that's 2, that's minus 1, minus 2. Now that will be 1, that will be 2, that will be 3, that will be 4. Now that's half, that's quarter. So when it's quarter, the y value is 2. When it's half, the y value is 1. When it's 1, the y value is 0. When it's 2, the y value is minus 1. When it's 4, the y value is minus 2. So this time you'll find the graph goes this way. So you can see what the graph looks like. Once again, that graph will go close to the y-axis. It will not touch it, and therefore the y-axis will be the asymptote. So the y-axis will be an asymptote. It's interesting to note that this particular point here now is the x-intercept, and clearly this graph will not, there is no y-intercept in this graph. This graph does not have a y-intercept. There is no y-intercept in this graph, because that graph will go there, it will go very close, but it will never touch. If it never touches, it will never cut. If it never cuts, there will be no y-intercept. So we're coming to graphs now where this graph has got an x-intercept, but it does not have a y-intercept. Alright, so that's the shape of all the graphs that will have a fraction as a base. If you have a fraction as a base, the graphs will have this shape. If you have a whole number as a shape, as a base, then the graphs will have the other shape like that. If the base is a whole number, the graph, right? So if you like, well, that's the graph of log of x to the base half. And then on the next graph that I'll do, I'll just draw the two graphs roughly to show you how it looks when the base is a fraction and how it looks when the base is a whole number. So what I'm going to do now, just to give you a comparison, I'm going to draw the two graphs on the same system of axes. So if you draw the graph of y is equal to log of x to the base 2, it'll pass through here and it'll come down here and it'll go up that way, and that will be the graph of y is equal to log of x to the base 2. If you draw the second one, then the shape is like this. It goes this way, down here, out this way. And that's the graph of y is equal to log of x to the base half. Alright? So that's the two graphs drawn together to give you a picture and for comparison. That means at any time, if I'm studying any question and if I find the graph is going in this shape here, I must know that the base is a number less than 1. It is a fraction, common fraction, a pure common fraction. And I must know that if the graph is going this way, then the base is a whole number. Then we know that the base is a whole number. Alright, so that is where we will run off for today. And the features of this graph, like we explained to you before, was that the y-axis, if you talk about features or characteristics, the y-axis is an asymptote, and number 2, the x-intercept is 1 and 3. This graph does not have a y-intercept, so there is no y-intercept. Alright, so now from these graphs you can find approximate values for, you can use this graph to solve equations, and your answers would only be approximate values in most cases. Only in some cases will you be able to get the exact answer. So what I will do, I'll just do one example just now where you're trying to solve equations from a log graph. Alright, so what you're going to do now, you're going to refer to the graph of y is equal to log x to the base 2. So there's the graph, and it's a rough graph, and we only want you to give us approximate positions. We don't want the exact answers. So there's -1, -2, 1, 2, and say that's 1, and that's 2. And there's the graph drawn for you. And that's y is equal to log of x to the base 2. Now the graph is drawn. You want the value of log of 3 to the base 2. Well, 3 will be here. So x is 3, you see? This 3 is actually x. That 3 is actually x. You see? That's really x. So x is 3. So if x is 3, then the value of log of x3 will be indicated there like that. So you want to know what is, indicate the value of log 3 to the base 2. Well, x is 3, I go up from 3 perpendicular, and then I go to the y-axis, and I find, well, it's going to be some value between 1 and 2. Second one. Indicate the value of x if y is equal to 0, 5. Well, this time I'm given the value of y. Y is 0, 5. So there's 0, 5 here. 0, 5 is here. So I will go to the graph there like that, and then go down towards the x-axis and say, well, that is the solution for, that is where the solution, let's say we call this A, and let's say we call this B. So this will be A, and this is where we will write down B to indicate where the solution is. And finally, show on your graph the value of x if log of x to the base 2 is 1, 5. So when you read this question here, this is really y. So this is really y. So y is 1, 5. So if y is 1, 5, then 1, 5 is somewhere here.